Question 1. So we've got to complete the Venn diagram. So this squirrely E means the universal set. So all of the numbers here have to be somewhere inside the rectangle. So we need to include all the odd numbers less than 30 either in the circles A and B or in the on the outside in the rectangle. So let's first of all go and put all our numbers in A, but bearing in mind that the 15 is also in B. So I put the 3, the 9, the 21 and the 27 in A, the 15 overlapping, so it's in A and B, and then B's got the 5 and the 25. So when we look at the A circle, that's got the 3, 9, 15, 21, 27, and the B circle has got the 5, 15 and 25. Now we've got to fill up the rest of the rectangle with all the other odd numbers which are less than 30. So 1, 3's already done, 5's already done, 7, 9's already done, 11, 13, 15's done, 17, 19, 21's done, 23, 25 and 27 are done, and then 29. Now, what is the probability that the number is in the set A union B? So this means it's either in A or B or both. So it's all these numbers in the two footballs. So we've got 1, 2, 3, 4, 5, 6, 7 of them. So 7 out of how many numbers in total? Well, 7 there, 8, 9, 10, 11, 12, 13, 14, 15. So it's 7 out of 15. Remember, always give a probability as a fraction if you're given the choice. Question 2. So as we've already got the x's lined up, we've got a 3x and a 3x, it makes sense to focus on the x's on this occasion. And as they have the same sign, I'm going to choose to take away the bottom equation from the top one. So subtracting them, 3x take away 3x is no x, that's what I was hoping. Y minus 4y, so y minus 4y is the same as y add 4y, which is 5y. And then minus 4 minus 6 is minus 10. So 5y equals minus 10. Divide both sides by 5, we get y being minus 2. So we can put that straight into the answer. Now to work out x, we need to substitute our y value of minus 2 back into one of our two original equations. So I've chosen to substitute it back into the top one, down here. So replacing the y with minus 2, I've got 3x minus 2 equaling minus 4. Add 2 to both sides, I get 3y equaling minus 2. Divide both sides by 3, I get y being minus 2/3. Question 3. So find the median size dress size. So the median is the middle one. Now we've got 25 women. So if we halve that, we get 12.5. Round this up, we're looking for our 13th woman. So as we do a running total of women, well, here are 2 women, here are 9 women, so that's 11 in total. Still haven't got to my 13th woman. So then move on and add on this additional 8. Then I do go past my 13th woman. So my 13th woman is in here. What is her dress size? Her dress size is 12. Now, 3 of the 25 women have a shoe size of 7. Zoe says that if you choose at random one of the 25 women, the probability that she has either a shoe size of 7 or a dress size of 14 is 9 over 25, because when you add them together you get 9 out of 25. Now this is only applicable if they are mutually exclusive events, if they are they're not connected. So if you were trying to, say for example, choose who came top in a class, and you picked one student and then a separate student, you could happily add together those two probabilities. But shoe size and dress size are not mutually exclusive events. It's quite possible to be in both categories, so you cannot do this. Question 4. So we really need to process all of this information. So let's think what we've got. We've got 420 cakes. Some are vanilla, some are banana, some are lemon, and some are chocolate. Now 2/7 of the cakes are vanilla cakes. So we can work out what 2/7 of the 420 is just by multiplying 420 by 2/7. So just in your calculator, use the fractions button to get 2/7, multiply by 420, and that gives us 120. So, and then for the banana cakes, we're told that 35% of the cakes are banana cakes. So again, using our calculator, 35% is 0.35. Multiply this by 420 and that gives us 147. So given we've got the vanilla cakes and the banana cakes, we can now work out how many cakes are either lemon and chocolate. So I have 120, add 147, take that away from the 420 and we get 153. So we've got 153 cakes that are either a lemon or chocolate. Now we're told that the ratio of lemon to chocolate is 4 to 5. So to work out the number of lemon cakes, well, it's 4/9 of the 153. It's 4 out of 9. So I've taken my 153, I've divided it by the 9 shares and then multiplied by the 4 because there are 4 lemon shares. This gives me 68 lemon cakes. Question 5. So we're being asked to show that polygon P, so this shape in here, is a regular hexagon, so a regular 6-sided shape. So let's work our way around this. So we know that we've got a 12-sided regular polygon here. Now the exterior angles of a regular shape always add up to 360. So given this polygon here has got 12 sides, so 12 exterior angles, each of these exterior angles must be 360 divided by 12, which is 30. So if each exterior angle of this 12-sided polygon is 30, then each interior angle must be 150, because exterior plus interior adds up to 180. So we know that this is 150 here. Obviously this is a square, so this is 90. So taking 360 and taking away 150 from it and 90 from that, we can see that the interior angle of this polygon is 120 degrees. So this is 120 degrees inside. Now if that's the interior angle of this polygon, then the exterior angle of it must be 180, take away the 120, which is 60. So we've established that each exterior angle of this polygon is 60. Now back to what we said at the beginning, for regular shapes the total of the exterior angles are 360. We've just established that each of its exterior angles are 60. So 360 divided by 60 is 6. So we've got 6 exterior angles. So 6 exterior angles must mean 6 sides, and therefore it's a hexagon. Question 6. So we know that density equals mass over volume, so mass must equal density times volume. So looking at the apple juice first of all, to work out the mass of apple juice, we're told that its density is 1.05. We're also told that its volume is 25. So the mass of apple juice must be 26.25. Now we can follow the same process for the fruit syrup and the carbonated water, just multiplying their densities by their volumes. So that gives us a total mass of 324.45. Now we know their total volume just by adding up the volumes we are given, which is 25, 15 and 280. So we know the total mass down here, the total volume is 320. So the density total must be the mass total divided by the volume total, 324.45 divided by 320, which is 1.0139 ... So to 2 decimal places, that's 1.01. Question 7. So we've got to calculate the length of AB. Well, this is a right angled triangle where angles are involved, so we're going to be using trigonometry. We're going to be using SOHCAHTOA. So picture yourself at the angle. that side is opposite us, that side is the hypotenuse, so we're going to be using sin. So sin the angle, sin 23 equals our opposite side, AB, divided by our hypotenuse, which is 15. So to make AB the subject, we choose to multiply both sides by 15. Popping that into our calculator, we are multiplying 15 times sin 23, making sure your calculator is in degree mode. We get AB being a length of 5.861 ... So to three significant figures, that's 5.86. Question 8. So I think a little diagram is going to help us gather our thoughts here. A square with sides of length x is inside a circle. Each corner of the square, each vertex of the square is on the circumference of the circle. The area of the circle is 49. Work out the value of x. So, okay, right. So what we've been told is the area of the circle is 49. So area equals pi r squared. So pi r squared equals 49. And so dividing by pi and then square rooting, we can see that r equals 3.949 ... Now the diameter, so 2 lots of the radius, is therefore 7.898 ... Now looking up here, we can see we've got a right angled triangle inside the circle. So using Pythagoras, we can say pi squared plus pi squared equals 2r all squared. So x squared plus x squared is obviously 2x squared, and that equals our 2r, our 7.898 squared, which is 62.388 ... Divide both sides by 2, square root, we get x being 5.585 ... So to three significant figures, that's 5.59. Question 9. So for part A, we're being asked to work out the interquartile range for the amount of money spent by these male students. So interquartile range is the upper quartile, which is 330. Take away the lower quartile, which is 150, which is 180. Remember how these work. This is the lowest mark obtained by, so the lowest amount of money spent by the male student. That's quarter of the way up. That's halfway up, so the median. 3/4 of the way up, and that's the amount of money spent by the most lavish of the male students, the most spent by one of the students. Right, okay. Part B. The table below shows information about the distribution of the amounts of money spent by some female students on the holiday. On a grid, draw the grid above, draw a box plot for this. So we start off with the smallest amount being 60, 180 is the lower quartile, 300 is the median, 350 the upper quartile, and 650 the largest. So that's quite straightforward. And then part C, Chris says the box plots show that the female students spent more money than the male students. The female students spent more money. Well, the median for the male students is 250. The median for the female students is 300. So yeah, Chris is fair enough. Chris is correct because the female median is higher than the male median amount. Question 10. So Naomi invests £6,000 for 5 years, interest rate of X%. At the end of 5 years, it's worth this. So we really want to be able to do this a shortcut way. So we have 6,000 being the initial investment, and our multiplier is 1.0 and then whatever the interest rate is. So that X within inside the decimal represents the interest rate. So for example, if the interest rate was 4% per annum, our multiplier would be 1.04. So 1.0x to the power of 5, 5 representing the 5 years, and we know that after the 5 years this is worth 8029.35. So dividing both sides by 6,000 we get this. I've then taken the fifth root, so basically putting it into the calculator to the power of a fifth. So that then tells me that 1.0x equals 1.06, so just sort of equating coefficients, x must be 6%. So just to recap, that bit there, I popped into my calculator like that. Question 11. So Jeff is choosing a shrub and a rose tree for his garden. At the garden centre there are 17 different types of shrubs and some rose trees. Jeff says there are 215 different ways to choose one shrub and one rose tree. Could Jeff be correct? So he can't be, because basically to get the total number of combinations you would do 17 times the total number variations of rose trees to give you the total combinations. So given when we work backwards we get 215 divided by 17 not being a whole number, Jeff cannot be correct, because 17 times the number of possibilities of rose trees will give you the total number of combinations. So working backwards, 215 divided by 17 has to give you a whole number. Question 12. So again, I think a diagram would just help us gather our thoughts here. So we're told that the ratio of AB to BD is 1 to 5. So that's what I've done there in purple. And then we're told AC to CD is 7 to 11, so that's what I've done there in red. Now what I can see is that I've got, looking at the purple one, the top one, I've got a total of 6 shares, 1 and 5 being 6, and the second one I've got a total number of shares of 18. Now it's going to be a lot easier to compare like with like if I have the same number of shares on both, so I'm going to choose to multiply the top ratio by 3. So rather than 1 to 5, I'm going to say 3 to 15, so I've got my 18 shares in common. So now it's easy to see what's going on. I've got 3 shares going from A to B. Given that A to C is 7 shares, that must mean that B to C is 4, because 7 take away 3 is 4. And then C to D I knew was my 11 shares here. So my relationship is 3 to 4 to 11. So for question 13, I've got to write down the 3 inequalities for the defined region. So first, let's start with the easier one here. This line here, I can see that all of the y coordinates are -2. For example, 2 minus 2, 4 minus 2, 6 minus 2. So that line there is y equals -2. Be very careful not to let it be, to think it's x equals -2. It isn't. Now this line at the top, if we can see, for example, we've got the points 2, 2 and 4, 4. That line is where y equals x. And then this, this lower line, the one with this a more gradual slope here, using y equals mx plus c, I can see that I've got a gradient of a half. My y step over my x step, this is my chosen triangle, is 1 over 2, and I intercept the y-axis at +1. So the equation of that line is y equals a half x plus 1. So step 1, establish what the 3 lines are, and now that we've got to fill in the appropriate inequalities for this region here. So this includes all the values where y is greater than or equal to -2. This includes all the values, so we're above this line here, where the y value is greater than or equal to the x value. So just check that out with the odd point. The y value is greater than or equal to the x value, whereas this one here, the one that's on top, is the other way around. With those, it's where y is less than or equal to a half x plus 1. So for these second and third ones, just choose a point inside the region and just double check that it holds. So for example, the point -2, -1, okay, there we have the, is it true that the y value is greater than the x value? Yes, it is. And then equally, is it true that y is less than a half of the x value plus 1? Yes, it is. Question 14. So with part A, when we have to simplify one of these algebraic fractions, we're going to have to factorize the numerator and the denominator, and then hope that, well, some of the factors will actually cancel down to allow us to simplify it. So first of all, factorize the numerator, and this is one of those difference between two squares where it is an x squared taking away a square number. So really I just think you need to learn that x squared minus 16 is an x plus 4, x minus 4, an x squared minus 9 would be an x plus 3, x minus 3, and so on. So, and then with the denominator, you need to factorize one of these where the coefficient of the x squared is not 1. So you can either do these by sort of trial and inspection, so just by sort of guessing the answers and then just double checking, focusing on the 2 and the minus 12, or you can do it my sort of longer way really. So the longer way is this. You say to yourself, what two numbers multiply to make minus 24? The minus 24 coming about by multiplying the 2 with the minus 12. So that's the multiplying equals minus 24. Yet at the same time, these magic numbers add up to be the minus 5, the coefficient of the x. And that is 3 and minus 8. Now we can't go straight to our final pair of brackets. This just allows us to break down the x term into two. So I've broken it down into a minus 8x and a plus 3x. It doesn't matter which way round you go. I could have written the plus 3x here and the minus 8x. Anyway, so at the moment we've just made the problem more complicated really. We've gone from 3 terms to 4 terms. Next step, you fully factorize the first 2 terms. So that is 2x open bracket x minus 4, and then fully factorize terms 3 and 4. So that's plus 3 x minus 4, and you will see you get this repeated bracket. Our final pair of brackets is then the 2 elements that are not in a bracket. So the first bracket is the 2x plus 3, and the second bracket is the repeated bracket, the x minus 4. So that is our denominator, and then as we were expecting, a couple of these factors cancel out, just leaving us with x plus 4 over 2x plus 3. Now for part B, we've got to make v the subject. So step 1, you want to move away from an algebraic fraction problem to everything sort of being on one line, if you like. So choose to multiply through by v. Now the next thing you want to do, we're making v the subject, so you want all the terms with v on one side, all the terms without v on the other. So if I just add 30v to both sides, I've got all the terms with v on the left and no terms with v on the right. I can then factorize the left hand side, so I can isolate the v. So I've no longer got the v cropping up twice, I've now just got v on its own. And then I can just divide through by w plus 30. So v equals 15t over w plus 30. Question 15. So we've got to calculate the value of x. Now we're told the area is 6 root 2. So our way into this question is to use the area of a triangle formula when it's not a right angle triangle. So our starting point is to appreciate the area of a triangle is half AB sin C, where A and B are the two sides which trap the angle uppercase C. So I'm calling this my uppercase C, this is my A, and this is my B. So substituting in, I know the area is 6 root 2, my little a is 2x minus 1, my little b is x plus 3, and I'm sinning 45 degrees. Now the sin of 45 is root 2 over 2, and I can see at that point my root 2's cancel. If I then multiply both sides by 4, and that gives me 24 on the left, and that undoes these two halves, leaving me with the 2x minus 1 x plus 3 on the right. Multiply out this bracket, set it equal to 0 by taking away 24 from both sides. I get this quadratic equation here. So my A is 2, my B is 5, my C is minus 27. Substituting that into the quadratic formula, I get x being minus 5 plus or minus root 241 over 4. Clearly x is going to be a length, so I only want the positive value from this, so I want the minus 5 plus the root 241 over 4, giving me the length x being, well, x being 2.631 dot dot dot, which is 2.63 to 3 significant figures. Question 16. So, with these, I feel these are never as difficult as they actually look. You've just got to appreciate that x to the base n is like the previous term, and x to the base n plus 1 is the next term. So, if we're saying the very first term, x to the 0 is minus 2.5, my x1 comes about when I substitute minus 2.5 into this. I will then get an answer for x1. And then to work out x2, I just substitute my x1 into this and get an answer for x2. And for x3, I substitute my x equals 2 into this to get an answer for my x3. So my x1 is when I substitute the minus 2.5 into this equation, giving me minus 2.64. My x2 comes about when I then substitute this x1 value, the minus 2.64, into the equation, giving me minus 2.573 dot dot dot. And then my x3 comes about when I go and substitute this x2 value into the equation, giving me this. So my x1, my x2 and my x3 are these values here. Now, part B, it says explain the relationship between the values of x1, 2, 3 and the equation x3, da, 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 da. So what I have to do, all I'm saying here is if I now go and just rearrange this, so the equation I've got up here, if I go and just say that set both of these as being x, if I then go and multiply through by x squared, I give x cubed equals minus 2x minus 4, add 2x squared and add 4 to both sides, I end up with this equation here. So what I can then conclude is that this iteration up here is an estimation of the solution of this equation. Question 17. So, could the average speed of the train have been greater than 160? So we need to find the upper bound for the speed of the train. Speed is distance over time. Now, if you're trying to maximize this fraction, you want the numerator, the distance, to be as big as possible, so the upper bound for the distance, divided by time being as small as possible, being the lower bound for time. Because when you are dividing, to maximize this fraction, you want a bigger number as possible on top and a smaller number as possible on the bottom. So the upper bound for distance is 275, because it's 270 kilometers to the nearest 10 kilometers. And the lower bound for time is 107.5, because it's 110 minutes to the nearest 5 minutes. So remember, for each of these, when it's to the nearest 5 minutes, the nearest 10 kilometers, to find the upper bound or lower bound, you just halve these restrictions. So that gives me 275 over 107.5. Popping that into my calculator, I get 2.558 dot dot dot. This is kilometers per minute. So to convert that into kilometers per hour, I multiply this by 60, giving me 153.48. So the maximum speed is 153.48 dot dot dot, so could not have been greater than 160 kilometers. Now we're told Jack's assumption was wrong. The track was measured correct to the nearest 5 kilometers. So explain how this could affect your decision to part A. So given it's to the nearest 5, we've got a less maximum distance. Our maximum distance is now going to be, we would be adding on 2.5 onto this rather than adding 5 onto this. So we would have less maximum distance, so the maximum speed would also drop. Question 18. So, The first thing to take on board is to remember that the angle between a tangent and a radius to the circle is 90 degrees, one of the circle theories. So we know this is a 90-degree angle here. So the first thing I want to work out is this angle x here, and that's within this right-angled triangle OAD, where 5 is my adjacent side and 9 is the hypotenuse. So cos x equals 5 over 9, so x equals inverse cos 5 over 9, which is 56.25 degrees. So given that this is 56.25, so will this be, because these are similar triangles. So this angle around here, this big angle here, completes the circle. So angle y is going to be 360, take away 2 lots of 56.25, which is 247.49. So I now know the angle within the arc ABC. So that now allows me to work out the length of the arc ABC. I know what proportion of the total circumference it is. So the proportion that this length here is, the arc ABC, of the whole circumference is y over 360, which is my 247.49 over 360, is that proportion of the whole circumference, which is, and of course the circumference is just pi times diameter, so pi times 10, because the diameter of the circle is 10. So this is the proportion of the circle, this is the circumference of the circle. That gives me 21.598 ... which is 21.6 centimeters to 3 significant figures. Question 19. So to start with, we have to factorize this quadratic. So what two magic numbers multiply to make -4, but at the same time, so that's 2 times -2, but at the same time add to be 3, which is a -1 and a 4. So I break down this middle term into being a +4x and a -1x. I fully factorize the first two terms, fully factorize the second two terms, and my final pair of brackets is the two components which were not in a bracket and the repeated bracket. So this left-hand side factorized is 2x minus 1, x plus 2. So a little sketch will help me gather my thoughts here. So my two solutions are going to be at, if this was equaling 0, my two roots are going to be where x was plus a half, that would make this bracket 0, and -2, making this bracket 0. Now this, given it's a positive x squared, gives me a positive parabola, so a smiley face graph. I'm looking where my solutions are greater than 0, so that is all the solutions above the x-axis. So I want all the solutions where x is both less than -2 and also greater than a half. Question 20. So we've got the equation y equals a to the x. A is the point where the curve intersects the y-axis. So that is when we've got an x value of 0. So we're nothing along the corridor. So x equals 0. Well, any number to the power of 0 is 1. So our y value is going to be 1. Now, given this circle here, where the equation is x squared plus y squared equals 16, from this we know, again that's just something you need to learn really, that it has centre 0, 0 and a radius of 4. This right hand term here, 16, is the radius squared. So I'm just drawing, well, we need to draw a sketch, so I need to draw, when I do draw my circle, my original circle would have a centre 0, 0 and a radius of 4. Now the circle is translated by the vector 3, 0 to give circle B. So we're just shifting this circle 3 to the right. So the centre is no longer going to be 0, 0. The centre is going to be 3, 0. So having a radius of 4, it's going to cut the x-axis 4 to the right of 3 at 7 and 4 to the left of 3 at -1. So here's my circle B. I've got the centre label with coordinates, the centre of B, there we go, 3, 0, and any point of intersection with the x-axis, well there we go, -1, 0 and 7, 0.